Okay, so I'm Chris, and at the University of Miami, or it's now the Frost Institute for Data Science and Computing, I'm the head of a group that does a lot of software engineering and data engineering, and we work with collaborators from all kinds of different schools and departments at the university. And so sometimes, we build like clinical research applications. We work with marine biologists and architects, but we also do a lot of geospatial related projects. We build a lot of applications that this is showing. It's an application to help explore affordable housing or inaffordable housing in Miami. And this is like a land use. I'm going to go through these really quickly because I don't want to spend up too much time, but there's different layers in these applications. Land use, elevation. This is another one where we did participatory mapping in a neighborhood in Colombia. Produced these kind of maps. This is a COVID dashboard, and like everybody, we made COVID dashboards a couple of years ago, and different scales showing different kinds of data summarized. And so to use, I don't know if you guys saw Brandon Liu's presentation, but to use, which is a great metaphor. So we build, like in our group, a lot of hamburgers. Like that's what we spent a lot of time doing. And in his metaphor, there's the buns. There's the bun people, and then there's the meat. And so each one of those applications you could think of as a hamburger, and we spent a fair amount of time doing it for other projects that I didn't show. And so at some point we had a need, or we developed this need to want to try to formalize and comprehensively manage our data. So that's what we're going to talk about.
And as much as I love this metaphor, and I really do, what are we missing here? I'm a restaurant owner. We're missing something entirely important in this metaphor that gets skipped over a lot in this conference, which is the data, the data acquisition and ETL. So we're going to talk about plates today. I don't know if you've seen this before, but this is a relatively old kind of joke about data science, about how everyone thinks that data science is really cool, but really we just spend a lot of time with data. And I think you could very easily cross that out and replace that with cartographers. That cartographers also spend a lot of time with data before they do anything at all exciting, right? And this is kind of a problem that we addressed in this hamburger making process that we're dealing with, is that we ended up reusing bits of data, but really data struggles to be fair. I don't know if you've heard of this acronym before, the findable, accessible, interoperable, and reusable. But GIS data really does struggle to be fair. And I'm not saying that there hasn't been wonderful work done with repositories. They're all over the place. They're really good. But for a research team to do interdisciplinary work, they usually have to go to 5 or 6 different places, get it all in from there, harmonize it, and get it ready to go before they can even take their first step of research. So this was the problem we addressed. And last year we presented on this here at NACIS about this containerized approach, where we're trying to build a cloud-native backend, highly curated collections of data that you can just kind of plug into research projects. If you want to know more about this, you can either see our presentation last year, or you can come and talk to us later. We're not going to talk much about this today. And to give a kind of a better overview of it, this is kind of what it's doing in terms that might be more understandable in this room, where we have a kind of a data curation side on the left there that's very human oriented about entering data into files. Then it goes into this Kubernetes kind of cluster that goes through that tool chain, and it produces endpoints that can be accessed through various different kinds of software like ArcGIS or QGIS or whatever. And with this, we end up with something that's somewhat scalable and flexible. And this is where we ended our presentation last year, so this is where we're starting it this year. There were 2 ways to scale this and to use it. One way, you duplicate the entire collection. We're not going to talk about that today, but it's relatively easy to do the way we've set it up. You can just deploy this and keep mirroring it wherever you want to and start, hopefully someday, federating metadata. Or the other side, which we're going to talk about today, you can break off bits and pieces of it to be that plate for our various different hamburgers. So this is the plate side of the scalability that we're talking about here. And I'm going to turn it back to Chris at this point.
So then I'm just going to show 2 different burgers, basically. One is like, a bacon burger, and the other is like a regular cheeseburger. So one of them is this thing called the Miami Affordability Project. that I mentioned, and it's basically an online GIS that has a curated, like a specific data set, so you can overlay various kind of demographic information, the location of public and subsidized house or assisted housing in Miami, and a bunch of other things, elevation data, heat data, and things like that. And so for that, we created in GDisk a collection with 21 layers. It has 15 vector layers and 6 raster layers. And this is what the catalog, the public-facing catalog for GDisk looks like for that. And so these are all the kinds of data that are in there, and they come from different sources. A lot of it's the city of Miami or Miami-Dade County, but there's also there's like internal. This data comes from the University of Miami itself, like in like research project at UM. So that's the kind of thing that's in GDisk, like a bunch of different layers and that look like this. And that's what a collection looks like. And so the way that we implemented this application that we call MAP, it's a multi-tier web-based application with this kind of stack. So it has so all of our map applications, we use Leaflet for the map part. And a lot of them are basically implemented like this with Node.js, and we index the data using Apache Solr. But the process for getting the data in for GDisk for this particular application is like, basically there's a guy, every once in a while takes the data out and we process it through an ETL pipeline that we've set up. And so like in a software engineering kind of system architecture thing, this would be like called a decoupled system, and because there's no real dependency. Like this thing will still run even if this isn't running, and this doesn't care at all about this. And so we can upload data whenever we want to. There's like full time, there's no dependency during runtime, but if we don't update the data, it might not be current, it doesn't have the most recent parcels in it or something, so we can automate it. But then we have this issue that comes up, which we call blindsiding, where somebody changes the schema at the public repository or whatever, and nothing that so it crashes. We can't update the data. So that's one kind of thing. So that's a decoupled system that we built. And then this is called the Displacement Vulnerability and Mitigation Tool. It's an application that Abigail, who's part of our at the university, spoke about this morning, and it's basically to help it's a tool for communities to negotiate basically with the local municipality and developers about the impact of a development project in their neighborhood. And I'll just do it really quickly. They go in, pick some parcels, enter some other data, and it computes basically a vulnerability index for displacement for that in that neighborhood. And then it helps provide a way for negotiating like mitigation efforts, and it's a very interesting tool. So it's another example of a hamburger, and this has also a bunch of layers in GDisk, and I could show them to you, but it looks just like the other one. So and so the architecture for this is a little different. Within GDisk we implemented an API that runs in GDisk, part of this application, like this, and then we built the other web facing part pretty much like the same way we built the other one. So this application makes API calls to GDisk in order to do some of the stuff that it's doing to work with that data. So this, in contrast, the other one is like a tightly coupled system, which means that there's this runtime dependency. So if this GDisk goes down, then this system doesn't work either. And so you have this possibility of cascading failures. But you're like, oh, but people do this all the time, like they call it Google API or whatever, like this kind of concept of like microservices, RESTful systems is out there, and it's totally possible, but it's mitigated by like high availability or redundant systems, which we're not going to implement at the University of Miami because we don't have the money to do it. That's what that $0 are for. And then even if you're using like something like a cloud service that somebody's claiming, they're maybe providing for free, it doesn't have to be free forever. They could put up a paywall in front of it, and then your system has this dependency on this API that doesn't work anymore. Like Stamen, I'm not complaining. Like Stamen has great like map tiles, but they took their map tile server down, and we had to rewrite stuff that was referencing that tile server, right? And so that's our motivation for what we're calling mirroring of these components, is to enable this idea of loose coupling. So and people often mitigate this or create this problem, do this loose coupling by making a cache, like on a mobile device, the phone's not always connected to that backend, so you cache data locally with the application. And that's kind of essentially our initial motivation for doing this. So we remove this runtime dependency, and then we just get the data as we need it from the central GDisk. But if GDisk isn't there, this will keep running locally. And so now this whole thing kind of becomes the DVMT. And the other thing that we can build into it, in the other case where it's already decoupled, is we can also mirror a piece of it with just that data for this one collection that's relevant to this application, but build in like maybe some software components that let you know when there's been a change to the schema, because we can have these two systems talk to each other, and this one can say, oh, there's been an update, and now this guy will know, and then he won't be surprised. That limits the surprises. So so the way we're implementing this is into the idea we have for the model is a two-stage mirroring. So we're staging software infrastructure, and then there's a part that mirrors the data after that. And so the first part that gets mirrored is basically a stack of things that manage. So this is Postgres, basically the data management. If there's any APIs that go with that collection, so in the collections, any APIs are specific to the collection. So they're built just for that kind of data set. And the collection is like this topically organized data. So there's one collection for the DVMT and one collection, say, for example, for that other one called map. And then the other pieces that come around with it. So these are just the data access parts. The other software infrastructure that comes with it is for mirroring that data. So ETL stuff and some process management. So once that's deployed, the second stage is to mirror the data. And then this part of the software goes and talks to GDisk at and if there's data to get, it gets it and puts it locally so that it's then accessible to the other, to whatever it's going to be used for. So, and then I'm just going to go over conceptually like how it's been implemented. So so these are the two phases. There's the deployment of the infrastructure and then this data mirroring control. And we use everything's running in Kubernetes, with Rancher and Helm. So I don't know if you're not familiar with them. I'm just going to describe them briefly. But Kubernetes is a framework for running containerized applications. Containerized applications, it's like a popular thing to do. It's like a cloud-based thing, and you get an image, and you can get them, and that image will say have an instance of Postgres in it, and then you can just run it like on your Mac if you're running the right containerization software framework. And Kubernetes coordinates, it's a management system for coordinating multiple of these containers, basically. And so in our deployment, we would deploy several different components. And in here, there's going to be Postgres here, if there were any APIs and whatever they're running, like a node, some scripts or to do ETL, this could be Python or shell scripts or whatever, and then another software application called Apache, and we manage this cluster using this software called Rancher. So I kind of described what Kubernetes is already, and it's a cloud-native project. Rancher is also, there's a free version of Rancher, and Rancher is basically software you can use to monitor and control the Kubernetes cluster, and it gives you, and I'll show that in a minute, an interface where it looks like this. And then Helm is like make for Kubernetes. So you can describe, so for each one of those containers, collections that we want to deploy, we'd have a Helm script or a Helm chart that takes all the pieces out in the data and describes how to build it within Kubernetes. So, and once that's deployed in Rancher, theoretically, it will work just like this. These are like Helm charts. You press a button, and it deploys it to your local Kubernetes cloud, and then you would get this empty container. And then after that's deployed, you can you can find this Airflow interface, which is basically a web-based interface that allows you to control when and how that data gets updated from the central repository over here, like this. So it facilitates this process and notifies also if there are errors or anything else. So there are a number of use cases that we have for it. One of them is the one I already described, which is this loosely coupled thing, like the DVMT, but others that we are using it for at that we're going to use it for is we have a project where we would it's a research project where there's some human subject research going on, but some of it is going to rely on a collection of public data that we can maintain in GDisk. and then we'll just replicate that to a secure local repository where these guys can work with their own data, but also work with this and not have to worry about, we can pull it through this firewall. Another kind of use case that we would use it for potentially in the near future is we're often get these jobs that are like data coordinating centers where there's a consortium, they give us the data, we link it, we put it together, and then we redistribute it to other organizations that are part of the group or the consortium, and this will help facilitate that kind of process. So that's a really quick overview of it.
And I want to just add one thing. So those of you who aren't familiar with Kubernetes, I started playing with it a couple years ago. You can run this locally on your machine as well, and it gets you past a lot of nasty install things. And you can run a cluster on your machine. So you don't need a cloud to run this. And as this kind of hints at, we have most of this going in a very beta version right now. That is the GitHub repo. If you're at all interested, we're kind of looking for people to join us on this adventure. I really see an enormous amount of potential in this future. And the other side that Chris just kind of mentioned is that there's this other way of mirroring as a kind of a consortium or something like that. And next week, I will be presenting at this conference, the Odyssey conference, which is all about linking patient health records to GIS data. And we're going to be using the other model in this conference to show how you can link that in and build these kind of private research things that have pre-built collections. One of the problems in research is these pre-built collections. So I think with that, we'll just say thanks, and hopefully you enjoyed my dinner last night as much as I did. It was a great excuse to take a picture of a hamburger.
So while Norris is getting set up, are there any questions?
Give just a little more detail on the blindsiding prevention.
So, have you ever worked with government data?
Can you?
So yeah, this is such a great question. So the question was asked about to describe blindsiding a little more, and I immediately asked another.
I think it's to prevent it.
Oh,
And so there's a
Yeah.
whole thing that I didn't show in there because it's like a little bit in the weeds, but we have like the basic process when you have it deployed, that the thing that Airflow is controlling is doing, it's going to go to an API on GDisk, check for the current, it gets like version information back about the data and the schema. And then it will go through, and if the schema has been modified, it will notify back through that same system, Airflow, that there's been a problem with the schema, and then it's up to the person on the other end to decide whether they want to continue with it or not. That's how it's going to work.
and I would just highly suggest you look into this cool thing called PostGIS, which is an API you can sit on top of Postgres, and it'll give you the schemas in a very nice kind of JSON-y thing.